So okay, here's the thing. I find that when I do when I sort of say like maximize performance of something, an LLM, when you don't give it anything, it will do really, like if it's testing in an LLM output, it will do really simple queries like 2 plus 2, 2 plus 3, 2 plus 4, and it'll do these really tiny queries, and it'll optimize for that. But the problem is that that's just not really a realistic depiction of what we do with these models these days. Like if you look at what I'm doing with this model here, it's an agentic workflow pattern where like I typed in something, it's like doing multi-turns. Each turn has reasoning that is cached and then resent back. There's just like a lot of stuff that's going on that's different than a hello world. What I want to do is actually create a little proxy that captures the traffic as it's going to the LLM. Like as it's going out of Pi and into the LLM, I want to just have a little proxy that captures that traffic and then saves it somewhere on disk, and then allows me to take those saved like in order proxied traffic and replay it and see, okay, are we making a real use case that we're really doing faster or slower? Captured proxy traffic could be replayed in a turn-by-turn way or teacher-forced way, and that the output of that replayed traffic could be measured for performance. Streaming probably uses streaming. Yes, it does. The proxy has to transparently pass through the SSE chunk, simultaneously record the complete request body and all stream chunks. This is a critical requirement. Yeah, that's true. I actually hadn't thought about streaming as much, but that's true. Needs to capture the request headers, the response status, all the metadata. Yeah. Please look at my Pi extensions and find the compaction chain one. Okay, so this is running through the proxy theoretically. It captures desktop. Cool, is it going through the proxy? We're capturing it. It looks like messages are being added. That was going to take 8 minutes at least. It was saying 12 minutes and 39 seconds. I'm thinking if we sample chunks of adjacent requests, but skip a bunch of the in between, could this be a command line argument for the bench mark? Okay, chunks K means how many windows to sample from each. Oh, okay. So total number of chunks. Chunk C, how many consecutive turns? Oh, so per chunk. So this is like number of chunks, and this is chunk size. Take 2 adjacent turns near the beginning, middle, and end. 3, okay. So I will pick chunk. Well, this will help me. Chunk 3 and 3. Okay, so this is the first chunk of 3. 1, 2, 3. And then it's probably going to do like, what is in the middle of 65? I don't know, 31, 32, 33 or something like that. And that's why it's taking longer, is because we jump to the middle. The ones that are in the middle have a bunch of prefix that needs to be prompt processed. So where's this going? We're still prompt processing that second chunk. The first one of the second chunk. Now I do expect that the second and third of that second chunk will be faster because it will have theoretically kept all the prompt prefix caching stuff going on. But we'll see. We're going to run against my desktop, which is a lot faster. And I'm going to use what is local? No, I want desktop. I'm going to test against the desktop with the captures from the desktop and do 3x4. You should see this. Yep. Okay, and it did. It did exactly what I expected, where it jumped up. It went through, it did it captured it. This is exactly what we wanted to see in terms of the benchmark. And that took what? 1 minute and 53 seconds? Those first three are pretty fast. but they were going to be. Like the middle ones and the later ones have more context. So this is where we're going to see the slowdown. I don't want timeouts. I'm glad I tested that. That might have actually caused like weirdness in the results. And yeah, at least the prefix cache picked up from where it was, but that wouldn't have been good. It's 30-second timeout? No way! Fail. I'm cheating and using Codex to do this. 30 seconds is not enough time. It took a lot of time, 413,000 milliseconds, but that intermediate one worked. Okay, once it did, how fast was the output? The output was 20 tokens a second. And then the follow-up, because this is like a chunk of adjacent ones, the prefix cache was reused. So this kind of is, I like this as a nice, reasonably good benchmark in my opinion that I created just now. Pretty cool. I actually feel good enough about this. Like this is a good enough benchmark to give directionality and not be just a toy benchmark.